Hello, we are starting Unit 10 today, which is a continuation of our previous unit, which was modeling. So, our previous unit was Unit 9, talking about creating relationships using functions, and we focused specifically on creating quadratic equations. Originally, Unit 9 and Unit 10 were combined, that you learned in one unit not only how to make quadratic equations, but also cubic equations and also variation equations. So there's a little bit of a continuation with what we did last unit. So make sure that you just are continually practicing what we did last unit, and because it will be probably on this test as well, um, as well as. I don't know what the end of that sentence is, but it's a continuation of our last unit. So we are today talking about cubic models. Our next unit, our next lesson, we're going to be talking about variation models, and then we'll bring it all together and talk about the three types of models that we've learned so far: quadratic, cubic, and variation, in our final lesson, talking about optimization. So it's kind of an overview of what this unit is going to look like. Let's go ahead and jump in. So, cubic models. What we're looking for with cubic models is going to be very similar for what we're looking for with quadratic models, except for with quadratic models, we had our highest degree, our highest exponent, our largest exponent was always going to be squared in a polynomial. With a cubic, our largest exponent, our degree of the polynomial, is going to be 3, right? If your largest exponent is there as a 3, then you know, oh, okay, this is going to be a cubic. Now, if you're trying to create a model, which now we know that that's kind of our end goal with all of these modeling lessons, our end goal is to create a model. The types of things that we're going to be modeling, the types of relationships that we will be modeling that will result in cubic models, are types of like three-dimensional space. That's our biggest thing. So, for instance, computer graphics. Computer graphics and computer programming work with three-dimensional space. It takes a 3D world and turns it into an approximation in a two-dimensional space. And so 3D geometry, 3 dimensions, means that we're going to be talking about an exponent of 3, cubic modeling. On that same line, if we have anything about volume pop up in a problem, that is also going to be a cubic model. So those are the kind of the main ideas of what we know is going to involve a cubic model. So the general form of a cubic model is f of x equals ax cubed plus bx squared plus cx plus d. And now we can see that we have how many unknowns. With quadratics, we had unknowns of 3, a, b, and c. How many unknowns do we have for a cubic? With cubics, we have 4 unknowns, which are your a, b, c, and d. With quadratics, when we had 3 unknowns, we needed 3 points in order to create a system of 3 equations in order to solve for our 3 unknowns. Since we have 4 unknowns, we are going to need 4 points in order to make 4 equations in order to solve for 4 unknowns. So that's why general forms of equations are helpful to see, is like, how many working pieces am I dealing with here? A, B, C, and D. How many of these pieces am I dealing with in order to know how to solve for those pieces? So since we see there's 4 unknowns, we would need 4 points and we're going to make 4 equations in order to create that model. This would only be for a systems of equations type of way of creating a model. We all know now that we also have like a very formula-based way of creating models, which is going to be a lot of what this type of modeling is going to be, as you'll see in our next video. Okay, today all we're going to do is talk about like bare minimum basic skills. So today is not IB level skills. It's how do we sketch a graph, which you are graded on, but it's kind of expected that you know how to do this already, as well as inverses, which we've already learned, but we're going to kind of recap. So sketching a graph. With quadratics, we needed to have a few key things. We needed to have our x-intercepts, which we could have at most 2 with quadratics. With cubics, we could have at most 3. We also needed to have our y-intercept, which will always just be 1 because functions can't have more than one y-intercept, or else it wouldn't pass the vertical line test. We also then check for vertices. Notice that this is the plural of vertex. So that's I-C-E. With a cubic, which a cubic can look like that, but doesn't always, notice that we have a maximum as well as a minimum. So now we're starting to talk about multiple vertex, or in other words, vertices. And those are the things that we need to graph. We don't have a line of symmetry really with cubic equations. So axis of symmetry is something we talked a lot with quadratics. We don't talk about those with cubics. These are the main things that we talk about when we are graphing. So I would like for you to find these values on your own. The way to do that would be to plug it into your calculator and find them. So go ahead and fill out this blank space stuff. So our x-intercept, which always has a y value of 0, is 6.67, if we're talking about three significant figures. Our y-intercept, which always has an x value of 0, is negative 12. And then our vertices are 0.306, negative 11.4, and that is our maximum. And then we have another one at 4.36 and then negative 44.7. And that's going to be our minimum. So hopefully we found all of those. We feel pretty solid. If you didn't get those values and you're like, where did those values come from? All you have to do is graph it on your graphing calculator and pinpoint those spots, right? Find your x-intercept by going to your zeros on your calculator. Find your y-intercept by just hitting trace and hitting 0, enter, because you're just plugging in 0 for x at that point, whereas plugging in 0 for y is a little bit more complicated on our calculators, right? And then our vertices, you just go to max and find your interval that you're trying to focus on, and then your minimum, you also find the interval that you're trying to focus on. Now, with all of these problems, we're an applications course, so we're dealing with real world numbers, and almost always the cubic that you're creating is not going to have nice values. It's not going to have like perfect, right? Like 0, negative 12, we're like, yes, that is a good point. And all these other points are like, these points are garbage. But this is real world stuff, and so it's good for us to practice real world things. A hint for sketching graphs is that more often than not, these points are not going to be super nice. And so go ahead and grab some additional points while you have the graph on your graphing calculator. Oh, additional points. Because you want to graph nice points, and your graphing calculator can find those for you. So if you just hit trace and plug in 1, right? If they're all being cubed, squared, and just kept the same, then like 1 will come out nicely. And so I found that 1, negative 14 was a point, 2, negative 24, 3, negative 36, right? If you just hit trace 3, enter, you get negative 36. TI Inspires and TI 84s, both of you guys. I also found 6, negative 24. So these are also some nice points that are just going to kind of give me a general shape of the graph that I don't mind graphing, and I don't have to worry about like approximating what these decimals mean. And so it'll be helpful in that way. When choosing where to put my axis, I practice it always. And I also have an answer key where like I messed up on one of the graphs, right? So like I also mess up. Some of you have asked me like, how do you know where to put the axes? And it's like being smart and thinking about it ahead of time and figuring out, okay, I go all the way down to negative 44 and I go all the way up to positive 6, which means on the y-axis, I need to span 50. And I go a lot heavy on the negative and not so much on the positive, right? So my x-axis can be a little bit further up because I need to go really far down in the negative, but not so much in the positive. So I kind of get a general idea of that. And then I try and think about, okay, well then where would my x-axis be? Well, my x-axis, I'm dealing with positive, 0, positive, positive. So I'm actually not dealing with anything negative. And I didn't grab any additional points in the negative. And if you looked at your graph on the graphing calculator, you can see that it's mostly in the positive direction, which means I'm going to put my y-axis somewhere over here. So I don't even really talk about those negative values. I just keep it there. So first, what I'm going to do is put in my y-axis, because I'm not super concerned about being able to go all the way up to 7, because I know I'll be able to reach 7 if I put my y-axis over here. And then I'm going to think about my y values in order to determine where to put my x-axis. I think I'm going to put it somewhere up here because I'm really heavy in the negative, not so much in the positive. I need to span 50. Whoops. Oh, no, that's fine. Oh, you might have been confused. And it's because I was misspeaking. 6.67 is an x value, not a y value, right? So I actually don't even need to go up anywhere on the y axis. I'm only going really negative. So I could even put it all the way up here because I don't care about the positives at all with this guy. So yeah, I'm going to do that, which is different than what I did on my answer key. Then I'm going to see how many tick marks I have. 1, 2, 3, 4, 5, 6, 7, 8, 13 to go all the way up to 45. I think 5 seems like a reasonable distance. I'll be able to reach 50 at least. And so that'll be good. So that's what I'm going to do. And that's kind of the idea of like, if I go by 1, 2, 5, 10 is kind of how I think about. I don't want my tick marks to be anything other than those numbers. Then I try and puzzle out which one's going to be the best one. So if this is something you're super confident on, I'm just droning on and over explaining stuff. Then fantastic. But if this is something that you struggled on, those are a little bit more of my thoughts on how I build the graph. I need to go all the way up to 7, which means I can actually go by units of 1 on the x-axis. I couldn't go by units of 0.5 because I wouldn't be able to get up to 7. Then I go ahead and graph all my things that are important. 6.67 is going to be like here. 1, -12 is going to be, 0, -12 is going to be like something right here. And then 0.306 this is 0.5. This is 0.25. 0.306 will be somewhere in the middle, but then it's, yeah, just somewhere here. And then -11.4, and that's a maximum. So kind of keep in mind that that's going to be like a little badoop. And then 4.36, -44, 4.36, -44.7, which is like pretty darn close to -45. So I'm going to put it like here-ish. Not exact, and these points aren't nice, right? So this is why I grab my nice points. Okay, well, an additional one would be 1, -14. Okay, that kind of like fits in with this idea of this little maximum. And then 2, -24 would be like somewhere right here. 3, -36. And we can see that since this is our minimum, right? It's going to look something like this. So notice only one x-intercept, whereas it could have more than one. Notice if my x-axis was like somewhere down here, I would have 3 x-intercepts. But since it's way up here, I only have 1. I do want to make sure that I label my axes x, y, and then I label my intercepts as well as my vertices. Similar to what we were doing with our quadratics. E basta. So using your graphing calculator, you have it available. So first step, graph the equation that you need to sketch, and then grab all of the important pieces, scale your axes, label the intercepts as well as the vertices, grab some additional points that kind of help with the shape of cubics because they're just a little bit tougher than quadratics. But that's kind of the general idea of how to sketch this graph. And the step 1 of it is always put it into your calculator because it'll be able to help you.